is M. Costa, and I am 1/3 of Facts Machine, a show by and for people who are curious about everything, but especially the things that make them laugh. In our show, we share fascinating facts we've discovered and the larger stories behind them, concluding with a pub-style trivia quiz loosely inspired by the theme. Tonight our theme is peace of mind, and we are aptly joined by two neuroscientists, science communicators, and all-around lovely brain havers, Dr. Chloe Lopez-Lee and Dr. Devon Collins. Yay! And one bad and brainy host and game master, Dr. Rob Frawley.
Hello!
So, Chloe, you study sex differences in neurological disease, right?
Yes.
Very cool. My question to you, though, is why are straight guys on dating apps so weird?
Science cannot explain. If I had the answer to that, I'd have a lot more friends.
Fair enough. Dr. Devon Collins, I wanted to ask you, because you also, from my recollection, study sex differences in the brain, yes?
I do.
Amazing. We have like a very, very niche, cool neuroscience crowd up here tonight. Do you have any insight on this issue from your experience?
I really wish I did. I guess I'm a guy, but I'm also not straight, so I don't think I can help with any
Fair.
of that. So,
I appreciate that. You don't share in the affliction I'm describing.
I'm afflicted, but otherwise afflicted.
Thank you so much for sharing. And Rob. So Rob, you actually studied bones in your PhD, as I showed briefly in the intro. But what are you studying these days?
Well, various things. I work on a bus for students. That is very fun. Yeah, buy a bus. Whoop, whoop.
But there's more on that bus than just a bus, right?
Yeah, there are microscopes
Okay,
and
yeah.
definitely like background checked adults. I promise.
Excellent. Yeah, your descriptor had me a little worried of like, it doesn't sound great to say, I just work on a bus with students for some reason. So, good.
No,
a little elaboration
People
helps.
know. It's all good.
Very cool. All right, so I think we should just move along into our first fact of the evening. So please join me in welcoming to the mic Dr. Chloe Lopez-Lee.
Thank you guys so much for having me. I get to study sex differences in the brain, which is so fun. But sometimes people get confused between sex and gender, so really quickly, we're just going to look at the genderbread person, right? There are so many things that comprise of gender. There's identity, there's attraction, there's expression. So I get to study the most fun part, which is sex, but not the kind of sex you're thinking of. So I study things like ovaries, testes, XX chromosomes, XY chromosomes, trisomes, like it gets really wild. And there are actually sex differences in so many brain disorders. So if you think of some of the brain disorders that come to mind, Alzheimer's, Parkinson's, schizophrenia, depression, all have sex differences. And it's not as simple as it's more men, it's more women. They're really multifaceted. They occur on a molecular level. It is pretty dope. And so I've been studying sex differences for 6 years now, which is wild. But over my 6 years of studying sex differences, there's one thing that I have really not been able to crack, and that is what sex difference explains my boyfriend's behavior. Like, for real. So, I have done a really thorough investigation, and I want to share my findings with you all tonight, the scientific community, right? This is peer-reviewed. So, year one of our relationship. You see where this is going. You guys already know. I love this. You're one of our relationship, right? The honeymoon phase. It's all great. You're like, oh my God, he's the best thing ever. This is amazing. Perfection, right? And then I noticed some interesting quirks. Like, he only calls me at 3 in the morning. And he's not out, like, raging at a club. Like, that's too cool, right? He's just calling me at 3 in the morning, and he's like, yeah, the weather's so nice here. I'm out taking a stroll. Like, how are you doing? And, like, how's the weather there? And I'm like, bro, it's dark. It's 3 a.m. Like, I don't, okay, cool. And he's like, yeah, I'm just, like, exploring abandoned buildings. And I was like, okay. So he's out getting asbestos at 3 a.m. But at the time, right, it's early days, and he had like a 3.9 GPA in college, so I was like, okay, he's a bad boy, but like he's like a nerd inside, right? Which is every girl's dream, right? It's like you have the bad boy exterior, and then there's like a nice nerd, and he's smart, and so I was like, okay, fine, we'll let it go. I go visit him on his college campus, and we have an assignment due in 2 hours. So we go to the library, and I'm like, all right, we have a deadline, we're gonna get this done. So I'm plugged in, my headphones are on, the keyboard is clacking. I'm like, we have things to do. And he gets up and does a lap around the library. And I was like, all right, maybe he just needs to stretch his legs. He's got to get the blood pumping to the brain. Like, I would know, right? Like, so I get it. And then he does it again. And then he does it again. And again. And then it's been 2 hours. My assignment's done. I'm like, great. So glad that's over. I look over, and I see him on Reddit looking up how a guy taught his cat to do skateboard tricks.
That's fair.
Yeah. Like, could that have been the assignment?
I mean, for calculus?
I was imagining, like, a thesis on, like, alternative modes of feline locomotion or something. It could happen. I've seen Stranger Things.
It could have been, like, physics of cat momentum. I don't know. But I can assure you it was not.
Fair enough.
The physics of meowmentum.
Hey, yeah,
Sorry,
that
it
one
was
was
right
good.
there.
I should just get off right here. You
Thank you.
please.
I had Schrodinger's half pipe, so like that's way better.
Wow. You guys are great. This is like the third time we're meeting, but you guys are great. So at this point, I'm like, okay, there's something wrong, right? I was like, the honeymoon phase is officially over. I was like, okay, look, no disrespect, dude, but like there's something fundamentally wrong with you. And you know the saying, they're like, oh, you catch more flies with honey than with vinegar, right? So I was like, you probably should go see a doctor. I'm really concerned about your well-being. I think you could improve your quality of life. But deep in here, I'm like, I can't live like this. Like, we gotta fix this. There is something wrong. So
I just want to say, I feel like this always happens
Yeah.
when like the female partner sees what happens on Reddit. Like this
I
is
mean-
just super consistent, and they IPO'd today, so buy in now, everybody.
no, really, I'd only been on Reddit before meeting him for like career advice. And
What?
I did, yeah. I mean,
Is that
There's
even
career
a thread?
advice on Reddit?
yes, there's some good
Reddit
career.
for everything.
I
It
don't-
makes sense, but
I mean, look at where I am now. I can't really tell you if it's
I
good
feel like
advice.
you're misusing Reddit.
But,
Yeah. The cat's on skateboards. I'm like, yeah, of course.
so, when you do that thing when you're sick and you have all these symptoms and you start to Google because you're like, I wonder what I have. And, usually Google is like, you're going to die in 48 hours. And you're like, all right, cool. So I start to
You're
Google.
on.
Yeah, literally, I start to Google. I'm like, let me see if I can figure out what he has before the doctor does. Before the certified medical professional does. And so I'm Googling around, and there's something that just really is hitting. Like, the symptoms are on point. And the symptoms are impulsivity, inability to focus, thinking without acting. I was like, ooh, that last one really got me. I was like, this is just lining up. And it's ADHD. Yep. Yes. Yeah, 100%. It's very common. It's 100%. Listen. And so one of the symptoms of ADHD is trouble processing input. So the time from which I told him to go see a doctor to when he realized what I was saying was 3 years. That's just how it went, right? Okay. So he goes to a doctor. The doctor is like, I'm going to give you a survey. I want 2 people who know you well to fill out this survey. He gives one to me, and I am like thrilled. Because I've been cataloging things, right? I know exactly what he did wrong. I know the day. I know the time. I'm like, I could write a dissertation. Like, forget a survey. This is going to be a piece of cake. No problem. So this is what my survey looked like. And so just for some context, right, here's a survey. Basically, there are a bunch of questions that are like, oh, are these symptoms, blah, blah, blah. And you rank on a scale, how does he exhibit these symptoms never/rarely or all the time? And as you can see, I was like, all the fucking time. Because it was true. It was true. So the only thing is, he said 2 people. He picks 2 people, right? The other person is his mother. Now, he's from Honduras. They don't really do ADHD in Honduras. They have other things to worry about right now. So his mother fills it out, and it looks like that.
So for the podcast audience, that has shifted from all 4s to all 1s.
Yep, perfectly balanced, right, as all things should be. So, there are questions like, does he fidget? I'm like, yeah, he's like restless leg syndrome mascot. And she's like, no, never. There are questions like, does he remember obligations? And I'm like, no, he forgot Valentine's Day. It doesn't get more obligatory than that. And she's like, no, he's good. And then there's questions, does he talk too much in social situations? And I'm like, bruh, I can't get him to shut up at home. And that's not really a social situation, it's just me. And she's like, no, he's a really shy kid. So needless to say, his diagnosis really came down to how good of a day the physician was having, right? Because these are 2 perfectly balanced evaluations. It really came down to the doctor. And I'm not going to say who's right or wrong, but he got diagnosed with ADHD. So, there was that. And, we're going to come full circle. There are actually a lot of sex differences in ADHD that are really, really interesting. Because a lot of what we know about ADHD symptoms are built off of studies of boys and men, and it is more prevalent in boys and men. But the primary symptoms that I described to you, the impulsivity, the inability to focus, the fidgeting, those are male-dominated symptoms. And those are called hyperactive symptoms. So when you look at a woman with ADHD, these symptoms are actually very different. They tend to demonstrate what's called inattentive symptoms. And that can look like lack of motivation. It can look like anxiety. It can look like repetitive behaviors. So you can see how if you don't know about the sex differences in ADHD, you might think that a woman with ADHD just has depression. But she doesn't. It's a lot more complicated than that. The treatment right now for ADHD is stimulants. And I know that might be a little confusing. You might be like, well, if someone's like impulsive and all over the place, like why would you want to give them stimulants? Like why would you want to stimulate them further? So let's imagine my boyfriend, right? So let's say you've had a really long work week, 100-hour work week. You've been sleeping 3 hours a night. You have been skipping lunch to work. So Friday night comes, and you're like so tired, right? You get home, what are you going to do? You're going to eat a bag of chips. You're going to change into your sweatpants without showering, and you're going to fall asleep on your couch because your brain is so exhausted that even though those aren't the best things for you in the moment, that is all you can manage to do. Imagine an alternate reality where someone gives you like tequila shot style, like a shot of energy. Or one of those like Panera supercharged lemonades. I mean, apparently they've been killing people. Like it's really bad. But you get energy.
I like the audiences you're appealing to with your distribution here.
Yeah. Really PhD heavy. Yeah. And so, you get this shot of energy, and you do things differently, right? Because your brain has the energy to make higher decisions. So you make a 3-course meal, you read, you do laundry, and these are all things that are harder in the moment, but are better for you long term. And that's really how stimulants work with ADHD. At baseline, untreated, the brain is so exhausted that it goes right into chips, sofa, sweatpants mode. And that makes it really difficult to plan for life, right? But when you give stimulants, those symptoms become manageable. Now, the only problem is that getting my boyfriend diagnosed with ADHD and, having him fix himself has really backfired. And the reason why is because before he was so busy managing his own symptoms that he never noticed when I was doing anything wrong. So I could just do whatever I wanted, right? Like, I came over, I was like, I'm not gonna put things back where I found them because he's messy anyway, right? Like you can't mess up mess. Like that's, and it's really Chloe's Wild West over here. And so when he started to take medication, he actually had the bandwidth to notice all my flaws, which. This is every girl's dream, right? Year 5 of the relationship, the guy realizes all your shortcomings. Like, that's totally normal. That's great. Sounds good. And he comes up to me one day and he's like, I noticed you've been really down lately. I feel like you haven't been very communicative. I noticed you don't put things back where they belong. Do you think maybe you have ADHD? So you guys, you heard it here first. Thank you.
For our second brain story of the night, please welcome Dr. Devon Collins.
I prepared for y'all a little neuroscience history lesson.
Woo, yeah.
Are you excited about that? All right, so what I want to talk to you about is some of my favorite historic brains from neuroscience history that have really taught us a lot about how like the human brain works in particular. So if you're ready, let's go. All right, so a really good place to start is like what makes the brain really special? And I want to tell you about kind of an interesting problem that I think neuroscientists face when they're trying to study their organ of choice. And it's not that it's only neuroscientists that face this problem, other biologists do too, but I think it's kind of uniquely hard for neuroscientists. And that is that when you look at the structure of the brain, it doesn't immediately like tie to the function of the brain in a way that's really obvious for other organs, right? And what I mean by that is if you look at an organ like the stomach or the heart that I have here, the stomach is a muscular bag with some like mucosa. It secretes acid. It holds onto food. It's got some valves that keep the food from moving before it should. And like if you look at it, it's a bag that holds food. Like that's what it does. Or the heart is a muscular pump. It's attached to a bunch of like valves and it's got some tubes and it pushes blood through the body. But when you think about the brain, like what the fuck does like what does that do? Like I don't know. So one of the things that neuroscientists kind of face is that like when we look at the organ, like we can't just say like, oh, that part does this or this part does this other thing. And so we're kind of relegated, well, not really relegated, but we have a unique opportunity to think about how behavior is shaped by the brain and how actually what happens when the brain gets kind of fucked up is a really nice way to learn about how the brain functions. And so that brings me to my first story for you, and that is the story of a man named Louis Victor Le Borgne. He was also known as Mr. 10, right? So here's his brain in a jar in case you're into that sort of thing. But so, I don't know what that meant. So Le Borgne...
Somewhere a podcast listener was like, oh, I wish I could see it.
It's a cool brain. Just Google, just do a Google. So Le Borgne was born in the early part of the 19th century. And he had a host of health problems throughout his entire life. From a very young age, he suffered from these bouts of epilepsy. But then later, he actually developed like hemiplegia, which is like paralysis on one side of the body. He also, really interestingly, and I think this is like the reason that he's most famous, is he developed this condition called aphasia, which is a loss of the ability to express speech or understand speech, or sometimes both. So by the end of his life, he was actually he was only able to articulate this one word, "tan," and that's where he got his nickname, Mr. Tan. So anyway, by the end of his life, he was only able to say this one word, and his doctors thought like it must have something to do with his brain. That was where a lot of people were looking for these kinds of behavioral problems. And it turns out that when he died, unfortunately, but I guess fortunately for neuroscientists, they found this like huge ass hole in the side of his brain, so this is the front, that's the back. In the front left side of his brain, they found this really big lesion. And they thought that this must explain what was going on, especially with his aphasia. So that's a really clear link between damage to the brain and behavior, but there's a problem with this story because we have no idea when that happened, right? So it's a little bit messy. So it would be better if we had a story where there was a clear beginning and end to, well, before and after, I should say. And I think, I love y'all. Y'all are great. I love you. You're my girl. I'm loving this. I'm loving these reactions. It's great. So I think you know where I'm going with this. And that's the story of Phineas Gage, who is perhaps the most famous brain in the history of neuroscience. And so some of you are probably familiar with this story already. But Gage was a railroad foreman, and he was blasting away rock to make way for some new track that was being laid, actually up in Vermont. And unfortunately, or again, fortunately for neuroscientists, he was the victim of a really grisly injury He was the victim of this really grisly accident in which this iron tamping rod that you see right in his hand there was driven by an explosion up through his jaw, behind his eye, through his brain, and then out the other side. It actually landed like 80 meters away.
So, Devon, I have a question about like accounts of the incident.
Yeah.
The tamping iron. When it came out of that gauge, was it doing just fine? Thank you.
And that, folks, is how
That's
it's done.
I yield my time.
That rod took a really interesting path through Gage's body, and it ended up destroying this part of his brain. This is actually this is obviously not his actual brain, but this is a predicted path based on the damage to his skull and firsthand accounts. So it ended up penetrating this part of his brain called the frontal lobe. And as many of you may already know, that's a really important part of the brain for like regulating a lot of the behaviors that we think are really important to our human social lives. And in fact, there are a lot of firsthand accounts of how Gage's behavior changed from before the accident and then after. And I'll just read for you here. We have been informed by the best authority that after the man recovered, and while recovering, he was gross, profane, coarse, and vulgar to such a degree that his society was intolerable to decent people. Before the injury, he was quiet and respectful. So there's a really profound change. And actually, a lot of these accounts of Gage's behavior may be a little sensationalized, but the effects are really clear. He had this big behavioral change after damage to his brain. And so that really highlights, damage to the brain can reveal a lot about how it works. But this is still a little bit troublesome because that was a very, and I'm sorry, messy example of how damage to the brain can change behavior. So we need something a little bit cleaner. And that brings me to one of the more recent stories that I want to share with you. And this is the story of a man named Henry Mollison, whose childhood problems with epilepsy ended up revealing a lot about how the brain makes and stores memories. So the story for Mollison goes that at a young age, he had these very terrible epileptic seizures. And they seemed to be pretty intractable to a lot of the treatments of the day. Like medications didn't work, other treatments didn't work. But his doctors were able to find where his seizures were originating in his brain. And it ended up being this little seahorse-shaped band of tissue on either side of the brain called the hippocampus.
Ever heard of it? Sorry, call back to a game that won't be in the podcast.
And the hippocampus, as you probably know, is really important in memory. But we didn't know that until after Mollison's story. And so his doctors were like, fuck it, we'll just take it out. It's causing the seizures, let's get rid of it. And so you can see, it's wild. They lifted the rest of his brain out of the way and then went in with suction and cauterization and just ablated his entire hippocampus.
Wow.
And it was kind of a success. So there you go, hippocampus missing. His epilepsy improved. He had fewer seizures. They were less intense. But something really crazy happened. He couldn't form new memories after that. He was essentially left with only the memories of what happened maybe years before his procedure. And he would meet his he would be like he was meeting his doctors for the first time every time they came into the room. He could only recall things that had happened maybe 10 years before the procedure. He could have conversations. He was completely normal in lots of other ways, but if he looked away, he would forget what he was talking about. And so this attracted the attention of a few different researchers, but I want to highlight this woman here, pioneer of neuropsychology, Brenda Milner, who worked with Mollison for most of the latter half of his life. And she's actually still alive today. She was born in 1918. She's 105 or 106 years old.
God.
She's fucking kill it. Neuroscience makes you live longer. So Milner had Mollison do a few different things to test how he could form new memories and do other tasks. One of them was this really interesting tracing task in which he had to trace the inside of that star, but he could only see what he was doing through a mirror. And as you could imagine, it's pretty hard. So every time he touched the line, went out of the line, or had to pick up his pencil and start a new line, that was counted as an error. And they would count the errors in every trial. And something really magical happened. they had him do this a few times, and he couldn't remember ever doing it or being exposed to it. But over time, he would get better at tracing the star. And that's really wild, because what that shows us is that memory is in more places than just the hippocampus. So even though he couldn't remember the who, what, when, where, why kinds of memories, he had what we call, like, more colloquially, muscle memory, right? And we know that that exists in other places like the cerebellum, and other kinds of memories like long-term memories are distributed around other places, like generally in the cortex. And that's really cool, right? And I've got one more story for you. Can I tell you one more?
Yeah.
Please do.
So this one is maybe one that you haven't heard of unless you're a hardcore neuroscience history buff.
So for just a second with the lights, I thought that was M's shadow behind us.
I did too, and had to stop myself from being like, we're good.
So I'm glad you said that, because there's actually a reason that we have a silhouette, right? So Henry Mollison died in 2008. And before he passed away, he was only known as patient HM. But SM is still alive. She's actually a woman she's about like in her 50s or 60s at this point. And so to protect her privacy, we only know her by these initials. But she's better known as the woman with no fear. And that's because she has a rare genetic disease that ended up destroying these two little almond-shaped pieces of tissue in her temporal lobes. Actually, they are right next to where the hippocampus is, right at the ends. And you can see here's a brain scan. We're in the 20th and 21st century now. So here's a brain scan from a healthy brain, and here's SM's brain. And those little black dots, or those little black spaces right there, are where her amygdala should be. And this happened to her when she was maybe in her teens, early 20s, and her behavior also changed very profoundly, and she was basically incapable of feeling fear that other people would feel. So researchers took her to like an exotic, oh, sorry if you're afraid of snakes.
But our audience, totally fine.
Amygdala's all around.
Yeah, your amygdalas are in good shape. So they took her to an exotic pet store to try to like have her handle a bunch of like tarantulas and shit and snakes. And she said that she's afraid of snakes. Like, so she'll by self-report say, I don't like snakes, I'm afraid of snakes. But she was like holding it to her face and like touching its tongue and like had no problem. They took her to a haunted house, like one of the most like haunted houses in like, I don't know the region, but like maybe the country. And she actually freaked out the people who worked at the haunted house, because she was like just stone-faced, like didn't give a shit, like didn't care. And then it also got her into trouble. Like on her way to work, she would frequently take like a path through this, or way home from work at night. She would take this like path through a vacant lot, and she actually got mugged at like knife point at least once. But she, at least at the time that I heard the story, was like still taking that same route back. And like anyone with intact amygdala would probably avoid that after being mugged. So she essentially felt no fear to like external stimuli, but that wasn't all. She also wasn't able to identify signs of fear in other people. And so if you showed her an array of like, these are some of those, like you've heard of like the basic emotions, right? Plus neutral face. If you had her appraise what emotions were here, she would be able to identify all but this fearful face right here. And so that was really interesting, right? She doesn't have these like fear responses that people normally have, but she also can't detect fear in other people. So what's going on there? So some researchers decided to look at that. So what they did was they had her look at a few computer-generated faces, and they tracked her eye movements to see what she was looking at, and also to see like, does she have some sort of visual impairment that was causing this phenotype. And what they found is that healthy controls would spend a lot of time looking at the eyes, but SM is kind of looking nowhere in particular. And it's a little bit easier to see on this heat map here. When people are just kind of like looking at the picture, they look at the eyes. SM is looking, I guess, kind of at the nose, which is like a very expressive part of the face, I guess.
What if she likes noses? Did they control
She might
for
just
that?
like noses. They should have built in that control.
She's like,
do you think
I'm not afraid of this, but that's a nice nose right there.
Do you think nose fetishists also have bad fear conditioning?
Yo, all right, I'm gonna
Am I
start.
spoiling something? Really?
No, that's not coming up. And so, what was I saying about this? So But what's really interesting is that if you instructed her to look at the eyes, so she's not looking at the eyes, just baseline, whatever she wants, she can't identify fear. But if you tell her, hey, look at the eyes on this picture, she's able to perform the task just as well as controls. So it's not gone, right? Her ability to detect fear is not gone, and it's about the attention that she's paying to the information that she's getting. All right, and I'm almost done. So that was really cool, but they wanted to see, like, okay, is her fear completely gone? And there are lots of different things that can make you fearful, threats from outside, but also threats from inside. And in M's honor, I had to say something about the lungs, so there are your lungs.
Look at the girls.
So the next experiment that I want to tell you about is, I don't know if it's a different set of researchers, whatever. They fitted her with a mask and pumped CO2 into the mask at sort of increasing concentrations. And what that would do in pretty much anyone, any human, probably most organisms that breathe, is it causes this really important and really strong autonomic response. You feel like you're choking. It's like apnea or asphyxiation. And so what happened with SM and a few other people who had similar lesions, so you can see no amygdala, amygdala gone, they rated it a really, really aversive experience, and they started to show the symptoms of a panic attack. But that wasn't all. I fucking love this story. They actually had higher ratings of panic than the controls. So everybody was panicking, but the people without their amygdala were panicking a little bit more, which shows that not only is the amygdala like important for sensing fear and evaluating fear, it might also be controlling panic in really tough, challenging times. So I think that's the end of the story, is it?
That's so cool.
Yeah, that's all I got. Okay, so one more slide for y'all. We have a lot of different ways of looking at the brain, not just brain damage, is how we find things out. And I gave you a lot of information here. What I'd like to leave you with is that if that broke your brain, please give it to me because I would love to study.
Our guests did the same animal brain themed trivia that you did. So let's find out how do you feel about the answers?
Yeah.
Max? Okay.
C's get degrees. Like, that's how we're feeling right now.
Okay. That's a good place to be. Got some, but also some room to learn, room to grow. That's good stuff. Okay, so question 1. What happens to male songbirds' brains during mating season?
So we said they grow bigger.
That is correct. There we go. Okay.
We know things.
Yes. Well done. Though E could be true as well, and I would honestly love to see that experiment. So in the spring, aka mating season, male songbirds have higher levels of testosterone, which increases the size of their brain and their testes. Unlike male humans, romantically inclined songbirds think with both of those organs. So, I'm dunking on a lot of things tonight. So most of the growth occurs in a part of their brains called the high vocal center, or HVC, which basically ups their singing ability and activity so they can competitively serenade their mates. So an amazing example of this is the Gambel's white-crowned sparrow, which doubles its HVC every mating season, and then they shrink it back down once the season is over. These birds have also been observed to grow their hippocampus during migratory periods. So truly, like, what a superpower. Very cool. All right, question 2. True or false? Sea sponges have no nervous system.
We said false.
This is actually true. Wow. The unbothered queens of the sea.
The neuroscientists are making eyes.
These are my favorite, of course. So sea sponges are soaking up everything but knowledge. And we think that's maybe by choice, and by choice I mean evolution. So a study of all the different kinds of cells in sea sponges identified one that kind of resembles neurons, but it's in their gut. This links back to a theory that sea sponges lost their nervous systems over evolution, suggesting that these cells might be related to the nervous system that they once had. These authors also posed this idea to sea sponges, but as far as we know, they're still digesting it. All right, question 3. Which creepy, crawly invertebrates can set unique traps for different prey, associate smells with rewards, and assess risk?
We said spiders.
That is correct. Yes.
Yeah. Biggest cheer spiders have ever gotten, I think.
Where did that come from?
Oh, that's my choir of kids that I brought. They're here to cheer.
On the bus, Rob?
Yeah. If the audience falls asleep, the kids always cheer.
Rob, school's been over for hours.
I know.
Oh,
they signed a
no.
permission slip once.
Okay. This question refers to a few different kinds of spiders. Orb weavers build different webs for different prey. Nectar-eating spiders were successfully taught to recognize the smell of vanilla and associate it with food. And teeny tiny jumping spiders, which are especially smart, have been observed to play mind games with their prey to lure them out, plan and remember routes, and consider multiple options for escape and then choose the least risky one. So we think this mental acuity might stem from the brain size in these little guys. A study looking at brain size in various spiders found the smaller the spider, the bigger the brain, and that some spiders' brains take up 80% of their bodies, actually spilling into their legs out of the body cavity. Yeah, just big, brainy, leggy guys. I love them. So, my opinion, spiders are the coolest, and I say this even though one crawled into my ear once. But, hear me out, he found his way out, so see, they're smart.
The trigger warnings we didn't have today. My God.
No, true. We had the snake, we had the spiders. That's the last of it, I promise. Question 4. Project SETI's mission is to detect and translate communication by what animal?
So importantly, SETI here is spelled C-E-T-I.
You caught it.
And so
Very
good.
good.
I hear the audience. Yeah. So we said broadly cetaceans.
Okay.
Oh, but maybe not.
I think that's okay.
Technically correct.
So, also, I had whales specifically. Technically, it's sperm whales, but cetaceans. I think they're all in the family. It's all
We're
good.
taking credit. Yeah.
Yeah. So Project SETI with an S is the search for extraterrestrial intelligence, and Project SETI with a C, I heard you, is the same. Got an astronomer over there. Is the same, but for cetaceans or whales. It's an interdisciplinary team of marine biologists, linguists, AI experts, roboticists, etc., seeking to record billions of sperm whale sounds and decode them into language for interspecies communication. Ooh. Sperm whales make a variety of noises, including clicks, trumpeting, buzzes, and chirps that a SETI scientist likened to rather intense farts. I guess he's heard some of those. And as with SETI, the debate has already begun on whether we should try communicating with whales. Proposals for our first sentence of contact have included sorry, which feels right for a lot of reasons, and what is the meaning of life? Which might reveal an entirely new form of whale communication, getting flippered off. All right, question 5. Which of the following organisms has 32 brains?
Is it D?
It is not.
No, I got all the wrong.
Anybody in the audience want to call out a guess? Yes, I heard C, I heard leech. You're all correct.
Son of a leech. Ugh.
Yes. So yeah, leeches, in my opinion, are proof of principle that you can have it all. And by it all, I mean hundreds of teeth, 10 stomachs, 20 eyes, 32 brains, and 18 testicles. These guys are ready to party. So, admittedly, 32 brains is kind of a technicality because they are all its brain, but there are individual units in each body segment. So that's how that works. Unlike earthworms, which have only one brain in their third segment, and actually, depending on the earthworm, can either regrow that brain if it's lopped off, or can only regenerate a full worm from the brain-containing segment. So for this question, I read further into the fascinating and unique biology of leeches, and as my gift to you, I will not be sharing any of it.
To leech their own. Yeah.
Gorgeous. Thank you for that. Question 6. The U.S. military, or true or false, the U.S. military trained pigeons to target missiles through the aptly named Project Pigeon. What do you think?
So our consensus here was that this definitely happened, but we weren't sure if the name was as dumb as Project Pigeon. We said true in the end. Is that?
Okay. So this one was a little tricky because the answer is false. But that's because
Project Flappy Bird? It's something like that.
so the CIA's Project Pigeon was proposed by famed psychologist B.F. Skinner in the 1940s, but it never took off, so to speak. Yeah, so it was an idea, but not executed.
Yeah.
And the
Probably
idea
the
itself,
name was bad. That's why.
that's
They called it something cool, it would have happened.
otherwise ironclad. That was the only problem, as I'm sure you'll agree. So the idea was to train pigeons, which have remarkable geographical memory, to recognize a site on land, reward them for pecking an image of that target site, and then stick them in a missile. Sure. They'd send up the missile, and then when the pigeon saw the target site through a little camera, it would peck the screen, driving the missile towards its target. So unfortunately, it would have been a kamikaze mission. Roost in peace, as we say.
Was the pigeon flying, or was it a passenger in the missile?
It was a passenger. Yeah.
That could have been any animal.
Yeah. Well, the idea was that they can memorize like specific geographic features very well. But yeah, it was silly. It didn't stop at the name. It was just silly. All right, question 7. What breakfast treat resembles the shape of a squid brain?
We decided to hedge a little bit on this one.
Okay.
We thought that it had like a ring-shaped brain. So we said Cheerios, bagels, Fruit Loops, and donuts.
So see, here's the problem. So I was backstage when my lovely guests and co-hosts were filling out their quiz, and in hearing them go through this, I realized, shit, a lot of breakfast foods have the same shape. So I had the answer as donut, but clearly, but any of those is right. Like mathematically, we'll call it a torus, but yeah, we really like eating rings for breakfast. I don't know what that's all about, but I guess it's a thing.
They wouldn't let me write onion rings because I was told that's not a breakfast food.
Onion rings are brunch. I could see them being brunch. But yeah, so cephalopods, like squids, octopuses, and cuttlefish, have torus or donut or Cheerio, etc., shaped brains. The hole in the middle is pretty narrow, and their esophagus actually runs through it, so they really have to grind up their food well, or else they can actually really hurt themselves and hurt their brains. In trying to wrap my head around this fact,
Oh, nice.
I didn't find many hypotheses about why squid brains are donut-shaped. A few sources suggested a role in processing visual information, but it seems, much like a squid's mouthful, that teuthologists are still chewing it over. The joke here is that teuthologists are cephalopod scientists. Okay, cool. And our last question. All right, so rank these organisms from smallest brain to body size to biggest brain to body size.
And just for the pod, can you read these animals for us?
Oh, so happily. A is the tree shrew. B is the bony-eared ass fish, which is a totally real thing. I love it. And then C is just humans. That's not as fun.
The ass fish of land, yes. So we went, I guess, phylogenetically, we went fish, shrew, human.
Ah, interesting. Okay. We were quite close. But actually,
Yeah.
we humans,
Yeah.
in this and
Yeah.
many things, are just mid.
Yeah.
We're just mid. So, yes, the bony-eared ass fish, an absolutely real fish, is described in Wikipedia as soft and flabby with a light skeleton, so I can only assume it also underwent 7 years of grad school. Thank you. These guys may have the smallest brain-to-body size ratio of any vertebrate. At the very least, they're really close to the bottom. And then there's us humans. And then at the other end of the scale are tree shrews, which have the largest brain-to-body ratio of any mammal. Tree shrews are also known for eating the alcoholic nectar of the Bertram palm and being near constantly drunk as a consequence, downing the equivalent of 9 glasses of wine per day.
Like a PhD student.
That's a lot. And also, to further imagine this, they are about 4 inches long. So it's a pretty high concentration of alcohol.
So how many brain cells do they have left?
Seemingly enough, because they show no signs of being drunk. It's a truly wild thing. Hopefully, our comparatively puny human brains can figure out their secret someday. But yeah, that was our trivia. Thanks very much. Great job, everyone. And Dewey, thank you so much, Noah. Okay, so now I can announce our winning team from the audience. Our winner with 6 points is Team Castor. Am I saying that right? Congratulations! Noah, I'm sorry for screaming into the mic. Noah edits, but he's very used to this from me. But thank you, but sorry. And then on Fax Machine, we also like to acknowledge the team that learned the most, because really, that's what we're all here to do, and laugh about it the whole time. So our team that learned the most tonight was the rodent deities.
Yeah! Rat God Life!
Woo! Rat Gods! Amazing. How is that not a band name?
What a tip of the hat.
Truly. All right. So, folks, that's all for now. Thank you so much for coming out. If you enjoyed the show, I hope you'll follow us on Instagram, TikTok, and Twitter at Fax Machine Pod, and go listen to, rate, and subscribe to Fax Machine wherever you listen to podcasts. Also, very importantly, please, the biggest applause that you have in you. Again, thank our wonderful guests, Dr. Chloe Lopez-Lee and Dr. Devon Collins. And I would like to ask, because I totally didn't click through all of this, you've heard me say that. Dr. Chloe, do you have anything you'd like to plug? I guess you do.
I mean, cats. Well, Noah was like, is there anything you want to promote? And I was like, what do you mean? And I was like, well, cats. So
Obviously.
Cats.
Have you heard of cats?
Yeah, have you heard of They're the best. They didn't go in a missile, but they're pretty dope.
Amazing. Knocking on your door. Have you heard of cats?
Yeah, cats are great. But also, there's this really amazing organization called Sanctuary for Families. It's one of the largest nonprofits servicing survivors of domestic violence. So you should donate your money or your time.
That is awesome. Thank you for sharing that. And Dr. Devon, would you like to plug anything?
Yeah, none of these are my personal socials because it's just pictures of my cat and dog, and maybe like a dinner that I had like 10 years ago. But I just wanted to plug these really awesome organizations that I work with or will be working with or have worked with. So BioBus, RockEDU at Rockefeller University, and the Dana Foundation, which sponsors Brain Awareness Week.
Give it up. Great, thank you. And yeah, so we do this show right here at Caveat on the third Thursday of every month. So that means our next show is on Thursday, there it is, April 18th at 7 p.m. It'll be loosely inspired by our home planet. We'll be joined by science comedian and journalist Kash Patel and geologist Christina Gustovich. So it's gonna be a great show. You should come check it out.
Yeah.
This has been such a fun show, such an awesome return to Caveat, and I'll remember it, honestly, very fondly. And I guess I have my brain to thank for that, whatever. But even more so, I have all of you to thank. So thanks again for coming out, and we'll see you next month. Have a great night.